MS Government Degree College, Autonomous, Mehboob Nagar. And my study project is Jignasa project is to study the characteristic curve of a transistor, common emitter transistor amplifier. So next so the co-participants are K. Naresh, Manjula, G. Bhaskar, and C. Naresh and M. Soni. We are BSc. Objectives of our project is to design a common emitter amplifier circuit to obtain the frequency response of an amplifier in mid-frequency gain and lower and higher cutoff frequencies. Next, the circuit diagram. The circuit diagram is divided into two modules. First module is this is the bias circuit and audio signal inputs. So a transistor acting as an amplifier, we can amplify the audio signal from input circuit to output stage of an amplifier. So here the R1 and R2 are used for the biasing of a transistor. In the input junction of a transistor is forward biased, and the collector terminal of a transistor is the collector resistance RC connected to a collector of a transistor which is always in a reverse bias. So in a transistor, the input junction of a transistor is always forward bias and output junction is always reverse bias. In this region, the transistor is in always an active region. So the transistor works under works phenomenon means transistor is always active region. In this notation, input junction is forward bias, output junction is reverse. I is used for the emitter resistance, which is always used for output signal is always sustainable region. So C1, C2 are the coupling capacitor. These coupling capacitors are mainly used for the impedance matching with the input stage to output stage. One stage to the other stage. So source signal stage to transient amplifier stage. After the amplification of the signal, the C2 is used for so coupling with the other stage of the amplifier. So which will use the total gain of the amplifier. Next here I is the emitter current. Whatever the charge carrier is transfer emitter, though current is the emitter current. Whatever the charge carrier mobilizing the base, though current is base current. And whatever the charge carrier is transiting the collector region of transistor, we can represent it as a collector current. So what is IC/RC and the potential across the output resistance is IC into RC. We are taking the output voltage between the terminals of the collector with the ground. This is representing it as Vout. Applied across the source 0 to 20 Hz are taken as low frequency signal, and 20 Hz to 20 kHz of the signal is always representing as frequency signal. Greater than the 20 kHz signal is always taken as high frequency signal. Next. The components in a circuit diagram. The transistor is always taken as CL100. The resistors R1 is 27 kilo ohms. 27 kilo ohms. R2 is always taken as 4.7 k, near under 5 k, and RC is always taken as 3.9 k. లేకపోతే దాన్ని కష్టపడి 4 k తీసుకున్నామని చెప్పొచ్చు. RE emitter resistance always taken as 470 ohms. బ్రాకెట్ లో చెప్తాం. ఎందుకంటే వీళ్ళ దొరకకుండా తీసుకున్నాం సార్ అని చెప్పొచ్చు. Next, emitter resistance always taken as 60 ohms. Capacitor C1, C2 are 1 microfarad. 1 microfarad. So bypass capacitor is always taken as 100 microfarads. Power supply is volts. That is VCC means of collector supply. Collector supply. So if in practically we are measure the output signal using oscilloscope. Cathode ray, that name of parent is CRO. Cathode ray oscilloscope. Then CRO. The function generator. Function generator is a source of input signal. Function generator changing of the signal is called function. Generator is pulse response. Whatever is generated will generate the AC signal, audio frequency signal in lower, mid and higher frequency region. Next, breadboard circuit. Practically we are circuit is constructed using breadboard and connectors. These are the components which are done in a experimental analysis. Next is common amplifier characteristic curve. This and it relates to the collector current and collector to emitter voltage. So collector current IC, collector to emitter voltage VC at different values of base current IB. And the transistor amplifier operates using an AC signal. That is nothing but audio signal. And the biasing of an amplifier provides the operating point of a transistor amplifier to receive the signals and reducing the distortion of a output signal. Okay. అది చూసుకుంటూ చెప్పాలి అంతే ఏం లేదమ్మా. నెక్స్ట్ అయిపోయింది. నెక్స్ట్ జస్ట్ చూడాలి, చూస్తూ అటు తార్షాలు చూస్తూ చెప్పుకుంటూ పోవాలి. The biasing voltage VB is equal to the total output voltage VCC into R2 by R1 plus R2. And what is B? B is nothing but a common emitter current gain, which is greater than or equal to 10 times that of the R2 by RB. 10 that of the R2 by RB. So from this they are taken B to E is always greater than 10 times R2, which is current gain of a transistor in common emitter configuration. So next, the coupling and bypass capacitor. Here the C1 C2 are used for coupling capacitor. So ఒకవేళ అడిగిన ఎందుకు ఉపయోగిస్తారంటే which can match the impedance or match the signal, transfer signal one stage to the other stage, and to separate the AC signal from DC signals using by the coupling capacitors, and it allows AC signal and with the DC component. A bypass capacitor is a circuit minimizing a good output stability. Is minimizing circuit is minimizing noise and చెప్పేసి and a good output stability కొద్ది చేంజ్ చేయాలన్నమాట. దీన్ని చేసి మళ్ళీ చేద్దాం. And a bypass capacitor short circuit with the emitter resistance RE, and at higher frequency region the RE increases the voltage to the maximum. దీన్నే కంటిన్యూషన్ చేయాలి. bypass capacitor short circuit with the RE emitter resistance RE, at high frequency RE increases a voltage gain to a maximum. Voltage gain, output voltage by input voltage, that is change in collector to emitter voltage by change in base to emitter voltage. The table. In table, we are taking the input frequency and output voltage gain. So from this, in table we are categorized different tables, different columns. So input, we are taking the input signal frequency. So we are taking the low frequency region 0 to 20 Hz is low frequency. In this notation, we are taking only 10 Hz, and mid frequency region 20 Hz to 20 kHz. In this notation, we are taking 100 Hz and 20 kHz. In high frequency, we are greater than 20 kHz. We are taking 30 kHz. So when we are taking the logarithmic of the input frequency is getting a value of, for that 10 we are getting 1, and natural logarithm whose value should be taken as log of the base 10 is equal to 0.4342 times that of the logarithm of function to the exponential function, which is equal to 0.4342, and when we are measuring the input signal using the oscilloscope, we are getting 1 volt. Output should be 1.5. The voltage gain, the ratio of the output and input voltage gives us 1.5. And similarly, at 100 Hz, so whose logarithm function value get at 2, and natural logarithm value should be 0.8684, and input voltage has getting 1 volt, and output voltage should be 2.2 volts using oscilloscope, and whose voltage will get a value, voltage gain get a value of 2.2 volts. It is a postmark. Next, so at a mid frequency, the upper value of mid frequency region 20 kHz, that is input signal 20 kHz, whose logarithmic function value getting as 4.30, and the natural logarithm value of the input signal is 1.86875, So when we are measure the amplitudes or voltages of the input signal using oscilloscope, it has 1 volt and whose output should be getting 2.28, whose voltage gain getting 2.28. So simply logarithmic natural logarithm of the frequency versus the voltage gain. Voltage gain is nothing but V output by V input. Here, when we are increasing the voltage gain from minimum to maximum value, low frequency region to upper frequency region. So, and measure the voltages along the along the voltage gain and plotting along the y-axis. We are getting a curve like this. And get a curve like this. From this, we calculated the cutoff frequencies of a graph by using so AV by root 2. 1 by root 2 times of voltage gain. 1 by root 2 is equal to 0.707. 0.707 into the maximum value. Maximum value is the graph వచ్చింది. So, so we are taking 0.70 times of the maximum voltage gain gives rise the cutoff gains. So, whatever the voltage gain, so 0.70 times of voltage gain cut off the frequency curve at the 2 points. So the first point is always taken as a lower cutoff frequency and upper cutoff point is always taken as upper cutoff frequency. So in real axis curve, in x axis, the low frequency taken from 0 hertz to the 20 hertz. And what is the region between the F1 to F2 or logarithm of F1 to the base 10 or next logarithm of F1 and F2 should be taken as the mid frequency region. So here the bandwidth should be taken as the logarithm of F2 minus logarithm of F1 is the bandwidth. That means of range of frequencies which are comes in mid frequency region. And the after the cutoff point F2, the frequency is taken as upper cutoff frequency. Here you can observe the frequency whose voltage gain should be constant sustainable only in the mid frequency region. But the frequency is increasing or decreasing. The gain should be increase and decrease. Should be taken place. Changing first taken place at lower and upper frequency, and mid frequency it is made a constant. Suppose next. The frequency response of the amplifier can be divided into three categories, three regions. So in this notation we are taking mainly concentrated and the mid frequency range. So the mid frequency range is always between 20 Hz to 20 kHz, whose frequency is called as a audible frequency. And so a mid frequency should be always calculated by a principle of so 0.707 times on value into AV into a class 1 లేదా AV by root 2 1 by root 2 times of AV అనేది maximum gain by root 2 is use the mid frequency region. Cutoff వచ్చిందమ్మా mid frequency region. It cuts the 2 points of curve. It cuts the curve in 2 points that are F1 and F2, and F1 and F2 are lower and upper cutoff frequencies. The bandwidth should be always taken as F2 minus F1. లేకపోతే లాభం F2 minus F1. ముందు చెప్పినంటే ముందు ఆడే చెప్పేస్తే ఏమవుతుంది ఇక చెప్పాల్సిన అవసరం ఉండదు. నెక్స్ట్ లోయర్ అండ్ అప్పర్ కట్ ఆఫ్ ఫ్రీక్వెన్సీ. At lower frequency the impedance of coupling capacitor should be increases. అంటే నేను ఆల్రెడీ చెప్పుకున్నామా XL is equal to 1 by omega C increases at low frequency. And the voltage gain of a transistor is amplifier decrease at low frequency range. Decrease at low frequency range and at high frequency. Decrease voltage gain low లో తగ్గుతుంది, హై లో తగ్గుతుంది, పెరుగుతుంది తగ్గుతుంది. గెయిన్ లో తీసుకుంటే ఏమవుతుందంటే అది వోల్టేజ్ గెయిన్ తగ్గుతుంది, లో లో తగ్గుతుంది, హై లో తగ్గుతుంది. అండ్ the reactance of capacitor as the frequency decreases and as the so చేసేద్దాం ఇప్పుడు చిన్నగా చేసేద్దాం దాని సిస్టంలో చేస్తా భాస్కర్ వస్తుంది కదా చేద్దాం next application. The transistor C amplifier mainly used in audio amplifiers. Advantages: the C amplifier is very rapid and efficient. Very rapid and efficient. Rapid and rapid
Speed.
easily spread, easily tunable and easily automated and that is changeable. Next, it has high impedance and low output impedance for voltage amplifier or nothing but a signal amplifier. Next, conclusion. So it allows coupling of AC signal into amplifier stage without distortion.